Okay, so we're going to do 7.2 day 3, although really this is kind of like a different topic than what we did. So before we did volume with cross sections, we're going to do a different type of volume now with solids and revolution, okay? So not an entirely different concept because it's the same section, it's all 7.2. But it is going to be a little different how we approach it. Okay, that's what the visual aids are for. So we're going to still we're still going to be making a 3D solid, but instead of making cross sections pop out of the base, we are going to be rotating the base around a line, always a line, and in fact always a vertical or horizontal line. Okay, very difficult to visualize. Again with the visual aids, I'm going to show you several things, but eventually you're going to have to kind of be able to picture it in your mind, just a little bit. Okay. If you know how to find the area of the base, like if you know 7.1 really well, which hopefully you're doing pretty good at it by now, and maybe not perfect, but better than you did before, and you understand what's in this box, you can do these problems. All right, so, and then I'll come back to this. So what I want to show you right now is this picture. Okay, so we have this graph. It could be a parabola or exponential decay. I'm not really sure. Okay, and what I'm going to do is I'm going to take this rectangle, and instead of making cross sections come out of it, which is what we did before, I'm going to rotate it around the x-axis. And by the way, everything that I'm showing you, you can do right here if you just click on this. You might have to like update your Java or allow it to run. If it may not want to run, you may have to make sure to say, yes, it's okay, it's not a virus. And so I'm going to show you what happens. I'm going to rotate this. It may not look like anything, but when I change the angle that we're looking at it, look what's happening. What shape is that making?
A circle.
A circle. Do you know how to find area of a circle? Then you know how to do what we're doing today. Pi r squared. Notice that the radius of this circle is the top minus the bottom. Does that sound familiar? That's exactly how we did area, and that is exactly how we did found the S when in the cross sections. Okay, so let me show you what this looks like when not just one thing is rotated around, but the whole thing. It's going to start at the back. Okay, and it's going to go all the way around. So notice that towards the right, it's really small circles, or smaller circles. And then as it goes around this side, it's much bigger circles. Okay? So that's what that's what the integration does. It adds up the area of all of those circles. Okay, so that's what we're going to do. We're going to basically integrate pi r squared, and the big thing we got to do is be able to find r. And that's how we're going to work about half the problems. Okay, the other half are a little bit different. What do you notice about this picture that's different than the other one? It does look like a leaf. So remember how that other one, it like went all the way down the whole way, it went off and touched the x-axis? Okay, this one isn't. Anybody have an idea of how that's going to change what happens? Okay, so let me change the angle a little bit. And I want you to see.
This isn't going to be around the x-axis. Right?
It's a washer.
It is a washer, and that's actually what we're going to call it. That's not even just a slang term, that's what we're going to call it. It's a washer. It's a circle with the middle part cut out. Okay? What you're rotating around, when the curve doesn't buddy up right next to that line and have that line as an edge, you're going to have a circle in the middle that you have to cut out. And so that's what we do. We call this a washer. So we have a big circle, an area of a big circle, and we have an area of a small circle that we cut out. And then that's one circle. And then if you want to make all the circles, watch what's happening here. These are making all the circles. And that's what integration does. Huh? Oh, that was just showing you what the center, like on the line. So it helps you figure out, like we have two different radiuses or radii on these problems, and that's going to help you figure out which one's which. And we're going to practice this on actual problems here in a minute. Okay, if I kind of turn this thing up, can you visualize that this is not completely hollow, but there is a hollowness to it? It's not filled in. Like, this is not like a bullet. It's like a cup. It really is more like those black things where you go like at the mall or the science place and you put a quarter in and it rolls all the way around. Like, if that helps you visualize that, and then once you get down to the end, this is so thin right here. Okay, that's like right next to it. Okay, so there's not an actual hole in this, but it's kind of almost there. So I kind of showed you this to give you an idea of what we're doing. Okay, the little yellow paper is designed to kind of help you with the problem that we're going to practice first. Okay, so just like the other problems, you have to determine if it's with respect to X or Y. You don't get to choose. You have to determine it, which is good. That means you're not going to pick wrong as long as you know this rule. If we're rotating around the x-axis, which the computer simulation, both of those were, or any horizontal line. This could be tricky because the equation of a horizontal line is y equals. And when you see, hey, this is rotated around the line, y equals 2, you might think that this is with respect to y. Okay? Oh.
Sorry to interrupt.
Okay, hold on. Okay, so back to what I was saying. It may be tricky because you may think, hey, if something's being rotated around the line y equals something, you might think with respect to y, but it's not. It's with respect to x. Likewise, rotated around the y-axis or any vertical line, so say x equals a number, that's with respect to y. You have to know this. If you get mixed up here, you have no chance of being able to do the rest of the problem. This is a very black and white rule. It's not an abstract rule. It's just black and white. Okay, what is the area of a circle, or sometimes this is called a disk? Pi r squared. Okay, with the washer, it's a little bit different because you have a big radius and then you have a little radius. Okay, so it's going to be pi big R squared minus pi little r squared. Or another way to write this would be to factor out the pi. Okay, the reason I'm factoring out the pi is because when we integrate here in a minute, if we put the pi here, we're going to have extra parentheses. And that, the more parentheses, isn't that just the more chances to make a mistake? So what we're going to do instead, whoops, didn't mean for that to happen, is we're going to put pi, the volume is going to be pi, and then do the integration piece. And so that's why I wanted to factor out the pi. And we can do that because pi is a number. All right, so let's look at number 1. And the first part is just find the area. Okay, this is something you should be pretty good at by now. If you're not, then we got to get you good at it. Okay, square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. And so that's what the square root graph looks like. And if you look at the little yellow paper that I gave you, it is this graph. Okay, y equals 0, that is just the x-axis. And then x equals 4 is this vertical line. Okay, so this is my area right here that I'm finding area of. Okay, if you got to choose which way you find area, would you choose with respect to x or y?
S.
S. So let's do that first, and then we're going to do y. So the area would be, okay, integration from what to what? What are the x values that you start and stop at?
0 and 4.
0 to 4. And then we go the top curve, square root of x, minus the bottom curve, 0 dx. Okay, and you type this in your calculator. If you don't have a calculator, then you do this one by hand. I don't need the square root of x, so I'm not going to type it in. That's not what I'm going to say. I don't need the minus 0, so I'm not going to type it in. It wouldn't hurt it to put it, though. It never hurts. You don't ever have to simplify that. That's the point I'm making. Okay. And I got 16/3. So you make sure that you're able to get 16/3. Okay, now, just for fun, right? This is everybody's idea of fun. We're going to do this problem with respect to y. And this is going to help us. I'm not doing this for no reason. I'm doing this because it's going to help us for the next piece. What do you need to do to that equation, y equals square root of x?
Do it in terms of
Square.
Yeah, get x by itself, so square both sides. So this is the equation I'm going to have to use for that top curve when I get to it. Okay, so the area is going to be, this time it's not 0 to 4, it's the y values, 0 to 2, bottom to top. And then the right curve minus the left curve. So the top curve, now I'm looking at it in a different way, and I'm saying that's the left. So we have x equals 4 over here, and I have x equals y squared here. So that would be 4 minus y squared, dy. You're going to type that into your calculator. And what do you think we're going to get? What should we get? We should get 16/3. If we don't, one of these is wrong.
So they'll be the same.
For area, doesn't matter how you do it, should always be the same answer. Okay, so that's all review stuff. Hopefully we feel better and better about that. Okay, what we're going to do next is take this shape and we're going to rotate it around a few different lines. So what I would like for you to do is to take your little yellow card, and if you're watching this video, you can just come see Ms. Brooks if you want to know what this activity looks like. You're going to take your little yellow card and you're going to cut out just the part that we would normally shade. Okay? And try to keep this in one piece, because what I would like for you to do is to tape this frame right here somewhere on your notes, just to kind of give you a reminder of what we're doing right here, just as a visual cue. Oh yeah, I remember we did this thing. And then your other piece of tape is, we're going to do something with that. We're going to take this and we're going to tape it to our pencil in different ways. Okay, so I'm going to go ahead and continue. If you're still cutting, go ahead and keep cutting. All right. First of all, A and B. Notice that we're rotating this figure now around the x-axis and a horizontal line. These are both going to be with respect to x, both of these. So I'm going to do these in red. Okay, you need to draw a new picture each time you do this. I didn't make you do this on the other one, but you need to draw it. It doesn't have to be super accurate, but it needs to be the general shape. Okay, now remember, this is the area right here. And in this first problem, we're rotating around the x-axis. That's how I know it's with respect to x. Okay, so they tell you which one to do with respect to x. All right, now there's a few different ways we can kind of visualize, because we got to figure out, is this a circle problem or a washer problem? And then we also got to determine what the radius is. All right, so a way you can do this without any like extra visual aid, and this is what you would probably do on a quiz or a test, is reflect your shape across the line that you're revolving around. And I kind of like to do it with like little dotted, so I know it's not the actual shape. And then you can kind of even make this 3D looking if you kind of, you know, if you wanted to. You see what this looks like. What do you think this looks like?
Circle.
No, like the 3D shape. What does this 3D shape look like? Kind of like a cone.
Bullet.
A bullet. It definitely looks like a bullet to me. Okay, so I want you on your pencil, okay? In other words, this is what you're going to do. You're going to tape your little thing, and your pencil is going to be this line of rotation, okay? So you're going to tape it, and I'll show you, but you're going to tape your pencil like this. So watch, look up here. Okay, you're going to tape the thing to your pencil like this. Sorry, like this. This makes more sense, probably
Is it
now.
okay if it's the other way?
Doesn't matter really in the end, but the long side needs to be taped to your pencil. Your pencil is the x-axis.
Crazy.
Okay? And all you got to do is twist your pencil around, and that shows you how this thing is rotating. Look, like this. Like this.
Oh, I used both my tape.
Here's the deal. There's more tape up here. You can reuse the tape, help yourself, whatever. Okay, so here we go. Do you guys see this shape? And if you kind of take your pencil and you go like this and you look at it from different angles, it's even easier to see. This I know doesn't help everybody, but for some of you, this is going to make the difference between do you get today's lesson or not, and that's why I do it. Okay, I have another visual aid, which is a little bit better, but we're not all making one of these. I have this thing, it's like one of those balls that you see like from Party City, and they're called Honeycomb Bolts, okay? And this is what it looks like. This looks like our shaded area, right? And where this string is like the origin, okay? If you rotate it around,
Oh my god.
and then you hold the two sides together, that's the shape that we're talking about. Okay, so if you look at it on the side, it looks like circles. Okay, I'm going to pass this around so that you kind of look at it and unfold it if you want to. All right, so however you do this, you got to come to the conclusion, okay, first of all, that this is a circle. Does everybody see that there's no gaps or holes inside? This thing is solid through and through. Okay, so it's a circle. What was the area of a circle again? Pi r squared. So the last little challenge you have to do is what is r? In a circle problem, your r is the same as how you did s. It's the same as how you did area. It is either top minus bottom or right minus left. Okay, in other words, in this one, it is the top curve minus the bottom curve. It's that distance right there. That's your r. So it's going to be square root of x minus 0. Do you need the minus 0?
No.
Of course not. Okay, so your volume. So with all that said, once you have that done, your volume is pretty much done. It's pi integration. This is with respect to x. So I'm going to integrate from 0 to 4 and my r squared. So square root of x minus 0 squared dx. Okay, and you're going to either integrate that by hand or type it in your calculator. I'm not going to show all these being typed in, but like since I already did this one, remember you can just go right before the comma x, go parentheses squared, and then open up another parentheses after the integration symbol, and I'm going to go ahead and put the pi in. You don't have to type the pi in. You could just know that your answer has pi in it. But what I find is when students don't put the pi in their calculator, they don't put the pi on their paper. And in these problems, you should always have pi as part of your answer. Always. Revolution, when you're revolving, rotating, you always have pi in your answer. Okay, so let's do the next one. Let's start by drawing the figure again. You don't have to put the minus 0. Okay, so I'm going to draw the picture again. I'm going to make it a little bit smaller.
Oh.
No, I'm not. No.
Okay, remember, you don't have to draw the full shape, but you need to have an idea. So I'm not even going to write the tick marks on this one. Okay, I'm revolving or rotating this around the line of y equals negative 1. You need to really understand that that is a horizontal line. And let me make that yellow, actually.
Totally sweet.
That's the line y equals negative 1, and we are rotating around that line. So without any visual aid, what you would do is kind of draw the reflection. Okay, and this is harder to visualize. When you're like, man, that's hard to visualize, probably because it is a washer problem. All right, here's what I want you to do on your pencil. I want you to take the thing and just have a little bit of space with the tape, like this. Leave a gap between your yellow little card and your pencil like this. This is what this problem is doing. And if you rotate this around, it's not making a solid shape. This is a clear washer problem because there's a gap there. Okay, I have another one of these little things. Okay, this right here is cut out. The origin is down here. So the x-axis would be here, totally, or the x-axis is here, but my line of rotation down here. Okay.
Yes.
Okay, so this one's kind of hard to show, and when I pass it around, that's probably what's going to happen. When you rotate this around, I'm going to kind of show this down the middle. There is going to be a hole, so for some of you big, right here in the middle. Okay, that's when you know you have a washer problem. These models are very difficult to make with washer problems. So if you're trying to think about what this looks like, it's probably a washer problem. Okay, so we're going to write that down. We're going to write washer. And then we're going to write the formula for washer, which is pi parentheses big R squared minus little r squared. And then I need to know, okay, what is big R? What is little r? Okay, I want you to watch this up here. Don't zone out on me here. Big R is going to be the top, okay, all the way down to your line of rotation. That's your big R. So in this case, it's square root of x minus, not 0, this is at -1. What is minus -1 the same as? Plus 1. So feel free to go ahead and change that to a plus. Okay, little r. Remember, there's two different ones. Little r is, this was kind of the shape that we were rotating. Little r is the inside. It's not even part of the shaded part. It's basically the gap. Okay, now if you're just looking at this and you said y equals 0 minus y equals -1, you might write this. But can any of you kind of tell, hey, those are both horizontal lines, therefore that has to be just 1. If you can recognize that, that's even better. Like if you can recognize that as 1. So once you get that, the volume really is just one more step. Pi, and you write your integration symbol, still 0 to 4 because this is still with respect to x. And then you have your square root of x plus 1, which is your big R squared, minus your 0 minus -1, or 1 squared. Did you need to put parentheses around the 1? No. And then you're plugging that into your calculator. Okay, I do want to show you this in the calculator because it's really easy to make a mistake here. So I'm going to start this one all over. So then we have pi, we have the integration symbol. Got to open up a second set of parentheses, and I am going to make a very common mistake, and I want you to see if you can catch it. So it totally gave me an answer, and this is the wrong answer. What mistake did I make? Yeah. Well, okay, I could have done that. That's actually going to give me the same answer as it did. Look at this first part. Look at what I have in my calculator here.
You need to make parentheses.
I just need square root of x, not square root of x plus 1. So I'm going to fix it now. I told y'all, I said, I'm going to type this in wrong, and I want you to fix it. I want you to catch it.
We got you.
Okay, 56 pi over 3. All right. So let's finish up this lesson with some that are with respect to y. How do you know these two are with respect to y?
Because it's the line x equals 4.
Right? It is a vertical line that we're revolving about.
Yes.
Okay, so this is with respect to y. Do you know right now if it's a circle problem or a washer problem? No, you've got to draw the picture. Okay, so draw the picture. Okay, 1, 2, 3, 4. And the line, I'm going to make this yellow just to kind of keep with what we've done. That's the line that you're rotating about. So without any visual aids, the only thing you got is to do something like this. If that rotates around, is that going to make a solid through and through, only circles, or washer? This is a circle. You can take your pencil and do this. I know I'm trying to do this overkill, but you can move the piece of tape to the inside piece, the short side, and put your pencil right up next to that short side. And then you can twirl your pencil around. I also have this one. Okay. It's not a circle, because it's a square root curve, but same idea. Not quite a sphere, it's a half of something that's curved. But it's not, or not even a half, but a part of it. But it's not a sphere, because to have a sphere, we would have had to have a circle as our base. All right. So remember, a circle is pi r squared, and then our r should be this way. Right minus left. Okay, so the right would be 4 minus the left is not square root of x, but with respect to y, so we need to do y squared. This is very similar to what we did right up here. Remember what I said, when you do a circle problem, your radius is just like your s, or how we did the circle problems should be, you should be like, good, thank God this is a circle problem, these are easier. Don't forget your pi, and my limits of integration now are 0 to 2, my bounds are 0 to 2, and I'm going to do the 4 minus y squared squared. Okay. Somebody figure that out and let me know what the answer is. And I'm going to move on to the next part. Okay, last part. 1, 2, 3, 4, 1, 2. All right, now, this piece is kind of different because I'm revolving about the y-axis, but that's barely even touching the graph. So what is your hint as far as is this a circle or a washer? Definitely with respect to y, and it looks like a washer. To confirm that, we can just reflect the line. Remember, your line of rotation, that kind of becomes like your line of reflection when you're trying to figure out what the 3D shape. What this shape is going to look like is, imagine you baked a cake, like a circular cake, and then the middle was like, the gravity was bigger in the middle for some reason, and the middle just sunk completely down to the bottom. There was like a hole in the bottom of the cake pan when you poured the batter in. I don't know. All right? And so it looks kind of like a cake where the middle is squished in and the outside edges are all normal. Okay, so remember for washer, we have pi, big R squared, minus little r squared. Okay, big R. Okay, remember, it's always right minus left or top minus bottom of something. When you're dealing with the washer and you say, okay, it's right minus left, you got to say right to the line of rotation. All the way across here. That's big R. So it's 4 minus 0, or 4. Okay, this is the line, x equals 4. This is the line, x equals 0. It's the right curve minus bottom curve. It goes all the way through the shaded region, outside edge, all the way through to the line of rotation. Your R, big R, little r, whichever one you do, is always to the line of rotation. So your little r, I'm going to choose a different color here. Your little r is that right there. So the little r is going to be not through the curve, but from the outside edge of the curve, y squared, minus the line of rotation, which is minus 0. I get that you don't need the minus zeros. I'm putting them in because what if we were rotating about the line x equals 3 or something, x equals 6. You need to have that minus 6 or whatever. All right, volume for this one, pi, 0 to 2 integration, and then big R squared. Are y'all comfortable with me just writing 4 squared? Minus little r squared. Again, I'm not even going to put the minus 0. This is y squared squared. Can anybody get the answer for part C? 256 pi over what? Sound familiar.
I got 16 pi.
Okay, let me just go ahead and do this up here just to make sure. I just want to make sure. I think I have these answers memorized, and then I'm like, I don't want to put it wrong on the video, especially. Okay, pi integration. So don't, y'all in here in this class, don't just watch me type this in. I want you to actually type it in as well. Okay, 256 pi over 16. So you probably just wrote it down wrong. But yeah. Okay, so this is 256 pi over, what did I just say? 15. All right. And then the next one, I'm just retyping. Okay. Pi integration. I'm going to just type it in as 16. That's totally fine. Minus y squared squared parenthesis y parenthesis 0 or comma 0 comma 2. Long day. Here we go. 128 pi over 5.